Across the lifespan, we grow from newborn to toddler to teen to mature adult. At each stage of life's journey, there are physical, cognitive, and social milestones. We're going to begin by learning about physical development. Now, through the course of this lesson, I hope to answer the following questions. How do the brain and motor skills develop during infancy and childhood? What defines adolescence, and what major physical changes occur during adolescence? What are the characteristics of emerging adulthood, and how do our abilities change from early to late adulthood? Having survived prenatal hazards, we arrive as newborns with automatic reflexes or responses that are ideally suited for our survival. Infants are born with these reflexes, and they aid in survival, and this includes the rooting reflex, which helps them locate food. And this will be the first reflex that we will be talking about. Rooting, this is when something touches the newborn's cheek. They turn towards that touch, open their mouth, and actively root or search for a nipple. Finding one, they quickly close on it and begin sucking. Grasping, this is a reflex that when they curl their fingers around an object, they automatically want to wrap those little fingers tightly around, especially someone's finger. That's a perfect size for them to wrap their little hands around, their little fingers around. The stepping reflex is something that newborns start stepping motion as they touch the surface. The little feet will start looking like they're trying to walk. And there are other reflexes we'll talk about, including we have the sucking reflex, and this is when they sucking rhythmically in response to oral stimulation. They'll suck on fingers and cheeks and chins, anything that you put in their mouth pretty much. There is also the moral or the startle reflex. This is when they throw their arms out, arch their back, and bring their arms together as if they're trying to hold on to something. This is usually into a response to like a noise or a sudden change in their position, or especially in the position of their head. It's like they look like they're panicking. And then there's the Babinski reflex. And this is the fanning or curling of the toes when their foot, the bottom of their foot is stroked. They're like the arch of their foot is stroked, and then their little toes will curl or fan out. So even as newborns, we search out sights and sounds linked to other humans. We turn our heads in the direction of human voices. We prefer to look at objects about 8 to 12 inches away. This just happens to be the distance between a nursing infant's eyes and its mother's eyes. Newborns also seem to have an inborn preference for looking towards faces. So their visual acuity, newborns, they see the best between about 4 and 30 inches away. Their vision is about 2600, which is not real good. They cannot see far away. They can see close, but not far away. And their binocular vision doesn't even really come together until about 14 weeks. By the age of about 6 months, babies develop depth perception, or the ability to see objects in 3 dimensions. Eleanor Gibson and Richard Walk devised this miniature cliff with a glass-covered drop-off to find out whether crawling infants can perceive depth. So this is the visual cliff that they used. They made this glass, and they had this little cliff, and there was actually glass that the baby could really crawl over. But even when coaxed, most infants refused to climb onto the sturdy glass over the cliff. We can see from the visual cliff experiment, as well as additional information that we'll be learning throughout this unit, that infants' physical psychological development depends on their biological development. From infancy on, your brain and your mental abilities develop together. On the day that you were born, you had most of the brain cells that you would ever have. However, the wiring among these cells, or your nervous system, was immature. After birth, these neural networks had a wild growth spurt, branching and leaking in patterns that would eventually enable you to walk, talk, and remember. So the developing brain, it overproduces neurons at first. So when you're born, there are 23 billion neurons. The greatest spurt is in the frontal lobe. This enables an individual to think rationally. This is the time to talk about maturation. This helps us understand not only physical development, but later on it helps us learn more about cognitive, social, and moral development as well. So this is a biological growth processes that lead to orderly changes in behavior. It's mostly independent of experience. So first, infants begin to roll over, they sit unsupported, they crawl, and they finally walk. So experience has little effect on this sequence. This is just the normal biological growth process, the steps that we take in order to develop. So, the motor development. As their nervous system and muscles mature, babies gain greater control over their movements. Their motor skills emerge, and with occasional exceptions, their sequence is universal. It's almost always the same. These are the abilities, these motor skills or motor development are the abilities such as grasping, walking, skipping, balancing. They all fall in that category of motor development. Now there are what we call developmental norms. Okay, this is the timetable during infancy that helps record motor development and spot possible problems. Children may not always fall in the right norm, but this is what, when pediatricians do appointments and things, this is what they're watching for to make sure there's not any developmental issues. The norms are where most children are at certain ages in their development. Okay, so motor development is an example. First, infants begin to roll over. Next, they sit unsupported, and they crawl, and they will walk. So 90% of all babies walk by 15 months old, but 25% will do it by 11 months, and 50% will do it within a week after their first birthday. But this is going to vary by culture. If a culture emphasizes walking, then the baby's going to walk at a younger age, and that's part of the nurture. If the culture instills walking is important and they do it a lot, that's the nurturing part. However, twins, they tend to work on the same day. They tend to walk on the same day. They learn at the same time. So that's another example of how important nature or the genetic influence in our development. Because remember, identical twins are they're identical genetically. They have the same genes. They have the same genetic makeup. Now, toilet training is one of those challenges that are kind of a nightmare for parents sometimes, but it really doesn't matter how a parent pushes or tries. The baby needs the physical maturation to hold his or her bladder or bowel movements before toilet training. So no training will work if the child is not physically ready. So do you remember your first day of preschool or your third birthday party? So most people can't. Psychologists call this blank space in our conscious memories infantile amnesia. Although we occasionally recall little from before age 4, our brain was processing and storing information before that time. So we can't really remember anything before 3 or 4 years old. This is then the first few months of life especially. Many neural connections that underlie memories are only beginning to form. There's a lot going on in there, but we just don't have a memory of that time in our lives. So infantile amnesia explains why 3- and 4-year-olds can't remember anything for the first few months of life. Many neural connections that underlie memories are beginning to form. So our earliest age of conscious memory is about 3.5 years. And a 5-year-old has a sense of self and increased long-term memory. This is when they really start to remember things. And as an adult, you can look back and you can remember quite a few things from your ages 5 and on. Let's move on to adolescence. During adolescence, we are morphing from a child to an adult. This is the transition period from childhood to adulthood. During adolescence, this is throughout the childhood, boys and girls are similar in height. But at puberty, girls surge ahead briefly, but then boys overtake them at about 14 years. Physical development during adolescence. Adolescents begin with puberty. This is the time when we mature sexually. Puberty follows a surge of hormones which may intensify moods and trigger a series of bodily changes. So this is a period of sexual maturation when one is now capable of reproduction. So this occurs earlier in females at about 11 years old, and then in males it happens at about 13. So in adolescence, these are the primary sexual characteristics of adolescence. In girls, we have, in women, male and females, we have the ovaries. In males, we have the testicles. Males have the penis, and women have the vagina. This is the primary sexual characteristic. These are the things that are involved in sexual reproduction. We call the primary sexual characteristics those body structures that are responsible for that. But then we have the secondary sexual characteristics as well. Now, these are not reproductive traits such as breasts and hips in girls, and these are the facial hair and deepening voice in boys. And there's also pubic and armpit hair growth in both men and women. So let's move on to the adolescent brain. An adolescent brain is a work in progress. This is the time when unused neurons and their connections are pruned. Until puberty, neurons increase their connections. However, at adolescence, selective pruning of the neurons begin. Unused neuron connections are lost to make other pathways more efficient. A teen matures, as they mature, their frontal lobes also continue to develop. But the frontal lobe maturation is going to lag behind the development of the emotional limbic system. That's where all the hormones come in. When puberty's hormone surges combine with the limbic system development and unfinished frontal lobes, it's no wonder teens are going to feel stressed. A lot of times they'll have impulsiveness, they'll have risky behaviors, and emotional storms, and it's no wonder because the brain development isn't quite up with the overactive limbic system and hormones. So the frontal cortex, during the adolescence, the neurons in the frontal cortex grow myelin, which is going to speed up nerve conduction. And also the frontal lobe lags behind that limbic system's development. So physically, cognitive, and especially socially, we differ at the ages 60 from our 25-year-old selves. Because there's so many differences, we recognize these differences and use three terms. We have early adulthood, which would be about 20s and 30s, middle adulthood, which is about 40 to 65, and then late adulthood. These are the years after 65. Now remember, though, that within each of these stages, people are going to vary a lot, especially physically. So let's talk about early adulthood first, because this is when we were at our prime. The peak of physical performance occurs around 20 years of age, after which it's going to decline for most of us. So after 20 years, physically, it's kind of going to be downhill. Now, middle adulthood. During the middle adulthood, physical vigor has less to do with your age than a person's health and exercise habits. Many of today's sedentary 25-year-olds might find themselves huffing and puffing up like 2 flights of stairs. When they make it to the top, they might glance out the window and they'll see their physically fit 50-year-old neighbor that'll jog by on a daily 4-mile run. Now, muscular strength, reaction time, sensory abilities, and our cardiac output decline after our mid-20s. However, depending on how physically active we are, that makes a big difference in our physical decline as well. Aging is also going to bring a gradual decline in fertility. At around 50 years old, women go through menopause. Men are going to experience a decreased level in hormones and fertility. However, for 35 to 39-year-old women, the chances of her getting pregnant after a single act of intercourse are only about half of those of a woman that's about 19 to 26. There is no menopause or end of fertility or sharp drop in sex hormones for men. They experience a more gradual decline in sperm count, their testosterone level, and so on. It just kind of is more gradual than it is with women. We have late adulthood. Although physical decline begins in early adulthood, we're not usually going to be very aware of it until later in life. Our vision's going to start to change, and a small, gradual net loss of brain cells begins in early adulthood. By the age of 80, the brain has lost about 5% of its former weight. So the average life expectancy in the U.S. in 2014 were females, it was 81, and males, it was 76. And life expectancy it varies depending on the culture and location in which you live as well. So the aging senses, with 70-year-olds, our motor abilities are really going to start to decline. A 70-year-old is no match for a 20-year-old. You can see from the graph that identifying smells, identifying spoken words, being able to identify letters and things with a chart, a lot of these senses are going to really drastically drop during the aging years. Also, adult health, there is some bad news. As we get older, our immune system begins to weaken. We are going to become more susceptible to very scary, dangerous, life-threatening ailments. There is some good news, however. Because of their experience, their large collections of antibodies throughout the years, they get minor colds left often because they have been exposed so many times to so many little viruses. Late adulthood, oftentimes we see the beginnings of dementia. Dementia is the deterioration of cognitive functions, such as memory and language. This is the most common thing that happens with dementia. So with increasing age, the risk of dementia also increases. However, it is not a normal part of aging. This is not something that everyone will experience. Also, in late adulthood, we have another thing to fear. We have Alzheimer's disease. This is the most feared of all the brain ailments. It's a progressive and irreversible brain disorder. It's characterized by gradual deterioration of memory, language, and physical functioning. You'll notice at the bottom how parts of the brain are shrinking, and each part of our brain has a responsibility. In charge of one of our senses, and our memory is a big part of our brain. It's like a huge storage computer. It stores so much information. And every time we lose parts of that brain, we're losing the storage capacity of this computer we have inside of our head. It also has responsibilities for helping us with our functions and our motor skills and our sight and our hearing. And so every time we lose parts of that brain, we lose those abilities.